Good morning, student. You are watching You Will Love Math for beautiful mathematics content and beautiful mathematics learning. So, today I will discuss the theorems on the tangent of circles. So, it's an important chapter and two important concept I will discuss. Two important theorem I will discuss. If we will get time, I will discuss another theorem of tangents on the circle and do solve problem solving. So let's start some discussion about tangents of the circle. So do you know definition of tangent? So understand first the definition of tangent. So before doing that, write down the problem or the statement of the theorem so that it will be easier for you to understand step by step. So the question is tangent and radius on the tangent and the radius on the tangent are perpendicular to each other. So tangent and radius on the tangent for a circle are perpendicular to each other is the statement of the theorem. So do you know what is perpendicular? Perpendicular means they are 90 degree, they are making 90-degree angle. So the thing is, what is tangent we will discuss first. So draw the circle with me or draw a circle with me. So after drawing a circle, I am drawing a secant. Okay, so do you know what is secant? Secant means a line passing through circle. Next another secant, then another secant, then another secant, and the secant is going to the ending point or ending section of the circle. So the distance between the 2 points on the secant on the circle are decreasing. So I am drawing like that, and d1, d2, d3, d4 are the distance between the points of the secant in the circle. So let's di. So if di tends to 0 of a secant, then we can tell that this is a tangent. So hope you are understanding. Di tends to 0 means the distance on the secant is decreasing. So you sorry, so you don't know the this type of definition in your class. It is a complex definition, but I am telling this because you will understand this type of definition in your class, and it is the definition from the calculus section. It is a definition of limit. So the I am telling you, and you are understanding a beautiful definition of tangent when the distance on the secant will tends to 0, then it is called tangent. That means the 2 points will be overlapped to each other. When the overlap to each other, then they will be down, then we will call that it is a tangent to the circle. So you have learned a beautiful definition, and the distance is decreasing here. Okay, so if the distance is decreasing slowly and coming to 0, then it is called tangent. Now hope you have understood the thing of the beautiful definition of tangent. Now come to the problem. What the problem is given: tangent and the radius on the tangent for a circle will be perpendicular to each other or perpendicular to each other. So with that particular thing, one thing is required. Okay, what the one thing is required? That the distance from a point to a line is perpendicular when it is least distance. So if it is least distance, then it is perpendicular. So there are multiple options to draw a distance or line from a point to another line, but the perpendicular distance is the least. So we will use this phenomenon, we will use this theorem, you can tell, and we will prove it, this theorem, with the help of that concept. Okay, so there is a circle with radius r, and there is a tangent passing through circle. So from the center there may be different distance r plus, like d1, r plus d2, r plus d2, oh sorry, I am giving l1, l2, and r plus l3, and r plus l4, and so on. So we can see here all the distance are greater than radius except the r, and r is basically touching the tangent. Okay, so every distance from the center to the tangent is greater than r. So as per the definition, only r is the least value or r is the smallest value. Since r is the smallest value, as per the concept, from a point, the distance from a point, the minimal distance to a line drawn, sorry, minimal distance from the point is perpendicular to the line. So r is perpendicular to the line ab. Sorry, r is perpendicular to the line ab. Hope you understood how we have proved the concept of that tangent and the radius on the of a circle are perpendicular to each other, and it is 90 degree. So here ODB is 90 degree. ODB is 90 degree. Fine. So here the it is making a right angle triangle, and both side ODB and ODA is 90 degree, and it is perpendicular on the line AB. So you have learned a fundamental proof of tangents and tangent of the circle and with the radius. So we will go in the next theorem, and the next theorem is, so there is one thing you need to prove, or you will prove in your home as an exercise, and if you don't do, I will prove it in the next class. So the second theorem, I am not proving it, but you can try it in your home, so that it will be an exercise for you for analytic thinking. So the second theorem is, I am not proving that theorem. So second theorem is, there can be only two tangent from an external point to the circle. So what is the thing? There can be only two tangent from an external point to a circle. So or to the circle. So only two, not more than two. Less than two, maybe one tangent we can draw. Okay, or there are only two tangents for, and from an external point we can draw. So we will go now the third theorem, and a very important theorem is the tangent from an external point to the circle are equal. Okay, so thing is, we will draw the thing, and from the previous theorem, as per the thing, there is only two tangents can be drawn. From that second theorem, we will go to the third theorem, or what the third theorem is, what the statement of the third theorem is, that if we draw that only two tangents, then the tangents will be equal to each other. So in the third theorem we will discuss, and first we will write the statement of the third theorem. So what the thing is, the tangents are will be equal to each other. So first let me write down the statement of the third theorem, and using the congruency property, we will prove the theorem. So now we will use the same figure. P is an external point, T1 and T2 are the 2 points on the circle where the tangent touch the circle. So the tangent, so let the statement with me, the tangent from an external point, the tangent from an external point to the circle point, to the circle are equal. So the two tangents can be drawn, so two tangents will be equal. So we will use the same figure and we will prove it. So how can we prove it? Can anyone guess? We will use the most important thing, the congruency property, and we need to prove it here. pt1 equals to pt2, pt1 equals to pt2. For that we will draw a point O, and as per the given figure, OT1 equals to OT2, since OT1 and OT2 will be radius. So there we are getting three lines, not three lines. For a triangle we are getting three lines, PT1 and PT2 for the two triangles, OT1 and OT2 for the two triangles, and OP is the common side. Now for the triangles, two triangles, we are getting OPT1 and OPT2. We will use the congruency property. So now OTP, OT1P or PT1O equals to OT2P or TP-T2O. Since what you have learned that radius and the tangents are perpendicular to each other. Okay, radius and tangents are perpendicular to each other. So what we will get, that right angle and a common side OP is hypotenuse, and that OT1 and OT2 are radius. So will it be SAS? No, it will not be SAS. It will be RHS. Why it is RHS? Tell me, anyone? So RHS will be here because in right angle hypotenuse side is using, we are using that property. SAS not be there, will not be there. I will discuss this on the when I will discuss the congruency property for class 7 and 8. I will discuss it elaborately. I am covering basically that 10 standard class right now, so I am not deep diving into detail for that. So RHS will be the congruency property to prove that the triangle OPT1 and OPT2 are congruent. So now after getting the congruency, what we will get? We will get the things are that angle T2P T2OP equals to T1PO. Is it? So what we are getting, write with me. First we are getting the lines are equal. PT1 equals to PT2. Fine. Now angle OP to T1P equals to OT2P. OT1P equals to OT2P. And the third angle T1PO equals to T2PO. So hope you are understanding this result or this correspondence value from the two triangles we are getting from here. Okay, so we are getting that result from the two equal tangent and the circle. So hope you have learned the theorems, and in the next class I will discuss some problems of the tangents on the circle. And if you have any doubt, you can ask me in the comment, and I will definitely answer of that question, so that it will be helpful for you to understand, to practice, to learn good mathematics with slowly and good quality content of mathematics. So I am covering small, or I am discussing small videos on the small videos, not extending the videos too much, so that it will be interesting for the student to understand in small class of a complex topic. So you are watching, you will love math if you are understanding, if you are liking, if you want to, if you are getting some knowledge from the channel. Please share that channel with others, please share the content with others. Thanks for watching for today's class, and hope you are learning good quality mathematics with You Will Love Math. Thank you for today's class. In the next class we will discuss another topic.